So welcome to today's chemistry lesson on naming and writing formulae for type 2 compounds. So these are with multivalent ions. So remember that a multivalent ion is in a particular element that can carry multiple charges rather than just one. So these are commonly found in the transition metals. Okay, so let's get started. So naming multivalent ionic compounds. For example, copper phosphide. Look up the metal on the periodic table and list the possible ion charges. Many transition metals are multivalent. Then we're going to look up the non-metal on the periodic table and identify its ion charge. There will only be one. So in this case, phosphorus has a 3- charge. Copper can be either 1+ or 2+. Then we're going to write the names of the atoms like you would for simple Ionic, meaning that we change the ending, in this case from phosphorus to phosphide. So rules for this, remember, are do not capitalize the name of the metal, so copper should be lowercase. And the thing that's different about multivalent Ionic versus simple Ionic is we want to separate the metal and the non-metal with a set of open brackets. So changing the ending, the non-metal to IDE as underlined. So our fourth step is to make a list beneath the formula of the anions and cations, remembering that anions are negative, cations are positive. So in this case, phosphorus only has the 3- charge. Based on the subscript, we need 3 separate coppers to distribute the charge. And this should total to the negative charge to balance it out and make it 0. So 3+ plus 3- would be an overall charge of 0. So the total positive charge of the cations must match the total charge of the anions. Meaning that in order to distribute this 3+ charge across 3 coppers, it will be a 1+ to total to 3. So 1+ plus 1 plus 1 gives us a total of 3+. Step 8 is to write the charge of the metal, the cation, as a Roman numeral inside the brackets. So because we determined that it was 3 copper 1+, that means that the overall charge is a 1. So in the corner here, I've provided you with a table. You should try and memorize these symbols as you will be able to write formulas more quickly this way. So now what I would like you to do is pause here and try out these 3 examples. Once you are finished, you can come back and double check your answers. Okay, so starting off here, we have a compound with cobalt and sulfur in it. So we're going to start by writing out the anion, which is sulfur, and checking our periodic table, this has a 2- charge. So the overall negative charge is 2-. Now we have 2 cobalts, as told by the subscript, and this needs to balance out to a 2+ charge. Meaning, in order to get a 2+ split between those 2 cobalt atoms or ions, we need an overall 1+ charge. So 1 plus 1 gives us an overall 2+, meaning that the name of this is cobalt 2 sulfide. I'm going to just show you the answers for this one rather than talk you through it. So it will just skip to the correct answer for this one. And our last example is a compound involving tin and oxygen. So just like with simple Ionic, we can use the crisscross method, but backwards, as a shortcut for naming multivalent Ionic compounds. So remember that this is a shortcut. So we reverse the process from yesterday's lesson to find the charges on each ion. So in this case, you take the subscript and it goes on top of the opposite ion as a charge. The 2 from the phosphorus becomes a 2 plus charge on the cobalt, and the 3 on the cobalt becomes a 3 minus charge on the phosphorus. Check that the negative ion has the proper charge. If it does, you can assume that the metal charge is correct and use that to write the compound's name. In this case, because cobalt has a 2 plus charge, it is cobalt 2 phosphide, remembering that you still need to change that ending to IDE from phosphorus. If the nonmetal charge, the anion, does not match, for example, in this case, if we take the invisible 1 from the phosphorus, it becomes a 1 plus charge on the cobalt, and we take the invisible 1 on the cobalt, and it becomes a 1 minus charge on the phosphorus. Because phosphorus must have a 3 minus charge, we multiply it by 3, and whatever you do to 1 in order to balance it means that we also must multiply the metal by this value as well, making it cobalt 3 plus and phosphorus 3 minus. Then we want to check the charges balance, so it should equal out. And then because it was originally a 1-to-1 ratio, a 3-to-3 ratio is still a 1-to-1 ratio. Then you can write the name of the compound. In this case, because of the 3 plus charge on cobalt, that means we have cobalt 3 phosphide. So take a moment to pause here and then try these 3 examples. So we have a compound that is made of Ti, which is titanium, and Cl is chloride. So this is examples using the crisscross method. So I'm going to write the ions below. So Ti for titanium, Cl for chloride or chlorine. Then I'm going to take the invisible 1, comes over here as a minus, and the 3 comes over to the metal and becomes a 3 plus. Check the periodic table to confirm that chlorine has a -1 charge, which it does. So this then becomes titanium 3 because of the 3 plus charge, chloride. Always remember to check your endings. The next one I'm going to walk you through just to be safe. I'll try and cut it down a little bit, but start off by writing your copper and oxygen down. So Cu, O, the copper's 1 becomes a 1 minus, and oxygen's 1 becomes a 1 plus charge on copper. Copper, open brackets, oxide. Now, when we look at our periodic table, oxygen should have a 2 minus charge. So because of that, we times it by 2. Whatever we do to this one to balance the overall charge, we do to the metal as well. So times that by 2, meaning that we end up with copper 2 plus, O 2 minus, which matches our periodic table. That means that this is copper 2 oxide. Last example, I will just skip through to give you the answer for. So now that you have checked those over, we are going to move into writing formulas. So writing formulas. Write the cation and ions down with their charges. The Roman numeral tells you which charge to use on the cation. So for example, iron 3 sulfide means that iron 3 is iron 3 plus, and sulfide we determined from the periodic table to be 2 minus. Count how many positive charges and how many negative charges there are. So in this case, we have 1 3 plus, giving an overall 3 plus charge, and a 2 minus from the sulfur. Add either the cations or the anions until the positive and negative charges are balanced. So this is just like naming simple ionic compounds. So in this case, we can also think of the lowest common multiple, which is 3 times 2 is 6. So in order to make 6, we need 2 irons. So 3 plus and 3 plus makes 6 plus, and you'd need 3 sulfurs. 2 minus plus 2 minus plus 2 minus is equal to 6 minus. So now that the charges are balanced, we can write the formula. The subscript means that we have 2 iron and 3 sulfur, which is sulfide. Remember that if there are any 1 plus or 1 minus charges, we do not write those down in our final formulas, so drop the 1s. So pause here and give these a try. So to walk you through these, we look at the Roman numeral for our charge on our cation. So lead is Pb, 2 plus from the Roman numeral. Oxygen from the periodic table is 2 minus, so 2 plus, 2 minus. These are already balanced, so it's a 1-to-1 ratio. So PbO is our final formula. Tin for oxide means that Sn is tin, 4 plus charge. Oxide is 2 minus, so 4 plus, 2 minus. These are not balanced. Lowest common multiple here, if you want to think of it that way, is 4, because we can take 2 times 2, which is 4. So we are going to add until we can balance the charge. This will take 2 oxygens to do, as an overall 4 minus charge, or plus charge. So then tin, we only have 1, and we have 2 oxygens as shown by the subscript. For the last one, I'm just going to skip to the answer. Okay, so hopefully you've now checked that all over. And then our last little section here is on writing formulas through the shortcut. So remember that the crisscross method from yesterday's lesson is a shortcut. You need to identify the correct charge on the multivalent metal prior to using this method. It is important to check for reductions prior to writing the final formula. So let's try a couple of examples. Here is the first set that you can, actually this is our only examples that you can try. If you are confused, I will walk you through how to do that. Okay, so starting off with our first example of lead to nitride. Lead is Pb, and the Roman numeral tells us that it is 2 plus. And then nitrogen is N, which has a charge on the periodic table of 3 minus. So we're going to bring the 3 down, bring the 2 down to the subscript position. So you'll have lead 3, nitrogen, which has a subscript of 2. So Pb3N2. Tin for chloride, I'm just going to skip to the answer. Okay, and then our last example is manganese to oxide. So manganese 2 plus from the Roman numerals, and oxygen has a 2 minus charge. So we're going to bring this 2 down, so it becomes manganese 2, and then oxygen 2. Both of these are the same, or they're both divisible by 2, meaning that we can reduce. So divide by 2, divide by 2. So we end up with MnO as our answer. So still a 1-to-1 ratio. So that is it for today's lesson. Please make sure you go back and watch anything that was confusing for you, and then follow through with today's schedule to make sure you've completed everything. And then we'll see you back in our next meeting.